Okay, some of you have asked me to solve some more problems from 7.2 in a way where you can see kind of the step-by-step process of thinking through how to solve these. So I'm working with the practice exercises that we went over in class. If we had time, may or may not have gotten that far in your class. And I'm just going to work through these so you can see the strategies and how they work. Rules we're going to use, the first 8 are all up here, like they will be on the test for you. You just have to decide which rules to use. So looking at this, I know I'm going to get a disjunction as my conclusion. So if I'm thinking disjunction, there are a couple of rules I might want to think about. One is addition. If I knew I could get the Q, then I know I could get use addition to add anything and make it Q or not T. I don't see any real good way to get the Q though, because I don't have any sentence letters I could use to get modus ponens. I don't have any not M. I don't have any not Q to use modus tollens, not M to use modus ponens. Don't have an R. I don't have a not T. These are all within these conditionals, and if it's inside a conditional, the only way I can get it out of a conditional is to use modus ponens or modus tollens. And so that doesn't look very promising. I have not M or R. For that, it kind of suggests disjunctive syllogism. But again, for that, I need a single sentence letter that's negated. And I don't have anything like that here. So how am I going to go about trying to solve this? Looks like I need a different rule. And which rule am I going to want to use? Put my conditionals back in here. Which rule am I going to want to use? Well, I do see another rule that has the or in it. Another rule that I can use to get something that has a disjunction. And that is the constructive dilemma. Look, the result of the constructive dilemma is going to be an or. And I can use constructive dilemma just in case I have two if-then conditionals separated by an and. One is true and the other is true. Then I show that the antecedent of one or the other is true, and that would show me that the consequent of one or the other is true. So if I know P or R, I can get Q or S. What that would mean for this, if you look at it, I do have, in my or statement here, I have not M, so either not M is true or R is true. So I have almost everything that I need in order to do constructive dilemma. The only thing that I'm missing is having two if-then conditionals on the same line, because you can see how here they are on the same line, but I can solve that problem, and I can solve that problem with conjunction. So I can just take lines 1 and 2 and add them together. So I have not M, and if not M is true, then Q. And I also have if R, then not T is true. And this was from lines 1 and 2, and the rule is CONJ, conjunction. So once I have that, I have everything I need using these two lines to do constructive dilemma. I know this or this is true. So I can conclude that this or this is going to follow. So I just really need one more line. This will be line 5. Here's my Q or T is true. And I used constructive, let's write that over here. I used lines 3 and 4 using constructive dilemma. This is the C here. And so here's what I have, Q or T. Here's what I was trying to prove. Sorry, Q or not T. Last I told you there. Here's what I was trying to prove, Q or not T. And so it looks like we completed our proof, and our proof is done, and our proof looks pretty good. All right, let's solve another one from that same sheet. We listed this as 4 because it's a 4 practice problem from the textbook. So for this one, we saw premise 1 is H or not B. And if that is true, then R. Premise 2 was H or not M. And if that is true, then P. Premise 3 is H is true. The conclusion I want to get is both R and P. So I can see that the conclusion I want to get to is actually a conjunction of R and P. Now, how am I going to go about getting R and P? Well, R and P, I can see, exist only 2 places. Here here's my R, so I'm going to want to go get that. Here's my P, I'm going to want to go get that, and I can use conjunction to put them together. So how am I going to get this R and this P? Well, the most obvious way, since these are conditionals, right, for the main connective on both of these, the main connective is an if-then conditional, and that suggests I can use modus ponens to get R and get P. But all I have here is H. So what am I going to do next? Well, if you're remembering our rules here, and you notice that after H, there's this rest that I need for both of these to do modus ponens, you can see that I can get the rest of those basically for free because I have the rule addition. So I want H or not B, all I have is H, but I can do H because that's line 3, or anything I want. In this case, I'll choose not B, and the way I'm going to do that is that's line 3, and that's addition. That's just what addition does, as you remember, right? Addition takes anything and lets you add anything to it as long as there's an or. Can't use an and, can't use an if-then, but if there's an or, right? Because if H is true, then H or anything is true, right? If it's true that you're a human, then it's true that you're a human or an alien, right? So as long as H is true, H or anything, but the anything I want in this case is not B, because that will allow me to do modus ponens here. So once I've done that, I have what I need to do modus ponens, because I have the antecedent to this conditional. So I can conclude that R from line 1 and line 4, and that's just the good old rule of modus ponens. Because I have the antecedent here, I can conclude the consequent, which is here. So what am I going to want to do next? Well, I can use the same strategy to get this P out, right? I have H, and I want to add to it. I can add anything after the or. That just is the addition rule. I'm going to add to it not M, because I can add anything. So I have H and not M. I used addition again, and I used the same line, because that's the H up there at premise 3. Addition to get H and not M. Then I am going to use modus ponens again. This is true, therefore this follows. That's just modus ponens. So line 2 and 6, modus ponens. And then, if we have on 2 different lines here, we have 2 things that we want to combine on the same line, because what we want ultimately is R and P. That's our conclusion. I have R, I have P, and that's just what the conjunction rule does. It allows me to take what I have on 2 lines and bring it to 1 by using conjunction, right? Because I know R is true, I know P is true, and so I know R and P is true. And that is just the rule of conjunction. I use lines 5 and 7 to get there, along with conjunction. So what I have now is I have a line I've derived with all the valid inference rules that's identical to the conclusion that I want, which means I use only these valid inference rules and steps to get my conclusion, which means I've proved that the argument is valid. From these premises, this conclusion necessarily follows using only valid rules. All right. Let's try then number 7 from your review sheet as well. If you haven't already done this, I really recommend that you're not just watching what I do, but you're trying to solve these as well. If you watch the video twice, then the first time, maybe you can just watch, but after that, go ahead and solve it on a sheet of paper for yourself so that you can make sure that you know how to do these things. The only way to really learn how to do it is to practice them consistently. So now is a good time to practice. I'll start number 7 here, and premise number 1 was not F or X. If that is true, then P or T will follow. If not F or X, then P or T. Line 2 was if F, then P. Line 3 was it's not the case that P. The conclusion I want is T. So we can always start by asking ourselves, is there anything I can do to reverse engineer this? I know I want this T. The only place there is a T is at the other end of this if-then conditional, right? There's a T right here. So I'm going to need that in order to conclude that T. I have an or here, which means there's a good chance I'm going to use something like disjunctive syllogism. If I can prove not P, that would prove that T. To get P or T out of here, I'm probably going to need not F or X. And you can see by looking at these some way I could do that. And if you're thinking that far ahead, that's great. But at least I have this much done. For most of you, you're probably going to only get so far with the reverse engineering, but it's worth it to at least think about how the reverse engineering would work. You can kind of, after some practice, pretty much solve them in your head that way, and then go back and finish it. All right, so if we're not reverse engineering, let's assume that none of that really made sense to us. That's okay. I can also just look at what I have and say, what can I do? And eventually, if I get to t, I'm set. No matter how many lines it takes, as long as I do only valid inference moves, it will be valid. So I have not p. This should look pretty familiar. I have an if-then conditional. One of them is negated, the consequent. I can also negate the antecedent. If f, then p, but not p, therefore not f. We know this rule well. It was the second one we learned. It's modus tollens. So that's line 2 and 3 with modus tollens. Now, what am I going to want to do next? I have not f. I see a not f here, but that not f is within this big conditional, and within the conditional there's also this disjunction, so I can't do much with not f. But I know I could do modus ponens over here if I had the antecedent. So this should look familiar to us and make me start thinking, well, maybe I want to take not f, that's line 4, and do some addition. What do I want to add? I want to add to get this, so I can do modus ponens to get this. So not f. After not f with addition, I can add anything I want, but what I want here is x, so that I can go on to use this as the antecedent to infer this consequent with good old modus ponens, right? So that's going to be line 5 and 1, line 1 and 5, modus ponens, and I can get out of that p or t, because I know not f or x is true. That's right here at line 5. I can infer that p or t is true, because that's just what modus ponens allows me to do. So I have not p or t. I got it from here using modus ponens. Now what I want is just t. So how am I going to use p or t to get just t? Well, this should have us thinking about the disjunctive syllogism. That's exactly what it does. It takes an or, here's my or, and if I prove half of it false, the other half will follow. And indeed at line 3 here, so I'm going to use line 3 and line 6, I have my not p, and that's going to allow me to conclude that t. Because either p or t is true, it's not the case that p is true, so it must be t that is true. And that's just the disjunctive syllogism. And so I've gotten the conclusion that I need, which was this t over here. I've derived it with valid inference rules. And so I have successfully proven that this is, in fact, a valid argument. All right, we might as well do the last one from the review sheet. It's number 13, because that's how it was numbered actually in the textbook for the sample problems. And we have premise 1. If C, then N, and E. We have premise 2, D, or if N, then D. We have premise 3, it's not the case that D, and we want to conclude that not C or P. Remember some of our strategy before. If we see a not C or P, or we see any disjunct as a conclusion, I'm going to want to be thinking about rules like addition. If I can get not C, I can get P for free. I want to be looking at other rules like constructive dilemma, which also gives me an or as a conclusion. I want to think about where these letters are here to think about how to get them. But look at the fact that P doesn't even exist over here. If that's true, I know I'm not using constructive dilemma as my primary strategy. It might be in there somewhere, but it's going to be addition because I have to get a sentence letter that's not even over here. And addition is the only thing that allows me to add a sentence letter. I'm going to have to add P. So I'm going to have to get not C. There's only one place there's a C, which is here. If I could prove not N, I could prove not C. But at least we could reverse engineer further, but maybe it's best to just start thinking about, well, as the strategies kind of like stack up, that can get confusing. So let's just start working with these to see what we can conclude, and when we have more elements, we'll be able to do more with them, and the strategy itself might start to become clear. So what can I do that's obvious then? Just thinking about rules I can use. The most obvious one that sticks out to me here is I have the workings of P or Q, not P, therefore Q, right? This is just the disjunctive syllogism right here, so I might as well use it to see what I can get. This or this, not this, therefore this. So I can get if N, then D, and I got it from lines 2 and lines 3, and I used disjunctive syllogism. Okay, again, let's pretend I have no strategy at all, but I'm just saying, what can I do? Well, I notice now that I have an if-then conditional here I didn't have before. It's separated out from this. I know this is true, not just this or this is true. So I have this if-then conditional separated out from this. And if I look at the line right above it, I should be thinking something like modus tollens. Because this is a rule where if I have if P then Q, not Q is true, I know not P is what's going to follow. So if N then D, not D, therefore not N. So I can conclude not N from lines 3 and 4 with modus tollens. Okay, let's go to line 6 now. What can I do with this not N, whether or not I have like any obvious strategy? I can ask myself, well, just with the things I have here, what can I actually achieve? I might want to look at the fact, because this not N, I can't use it here. It's a not N, so and it's trapped with this or. What about using it up here? Well, this not N could allow me to use modus tollens on this if-then conditional, but right now the main connective is this, right? And I need to operate on the main connective. So if I get if C then N on its own, I know I can simplify. I can simplify to get if C then N on its own, so I can use not N to get not C, and I can do that using modus tollens. So that's going to be lines 1, well, just line 1, because all I'm doing right now is getting this by itself, right? So just line 1, I can use simplification to get if C then N. Now I'm working on a strategy here to get to not C. Who knows how how much I've kind of like thought about this in advance. You remember, if we had not C, we knew we could get not P through addition, so we kind of had that in our mind already. We're getting closer to it because now with lines 5 and 6, I can use modus tollens. If C then N, not N, therefore not C, is just again what modus tollens does. Now I have not C, and I'd already thought about this fact that getting a P is going to require addition. So now we're to the point where we can do this addition step, and we can say not C or P, and this is from line 7, and this is addition. Addition is that rule that lets us add anything to not C, which we already had, and what we need is or P because that's what we want to get. And you see now that this is identical to this, which means that we have in fact completed our proof. Now, one thing that you'll notice if you were looking at the solutions that I went over in class, if we got that far, is that this is the solution that Hurley gives, but if you start solving it, you'll realize that there actually are other ways to solve this problem. So remember, these are all valid inference rules, all the ones we used. So many times there'll be more than one way to get to the conclusion from the premises, because the valid inference rules are themselves redundant. Many of them can be derived from other rules. So let's think about what that might have looked like. If you're solving on your own, you might have done something different. So I'm going to erase these last two steps of the proof. And let's take a look at what we have here. Notice we have if C then N, and if N then D. If you remember the way that pure hypothetical syllogism works, that's exactly how it works. When we have a sentence letter as a consequent and a sentence letter as an antecedent, in other words, as the first half of a if-then and as the second half of an if-then, we can join the other two letters with an if-then conditional. So that's exactly what I have here. I have an N here and an N here, which means I can join these two as my conditional. If C then N, but if N then D, so if C, I'm going to get all the way to D if I follow this chain. So I could go to line 7 here and get if C then D, and I've used line 4 and line 6, and I used rule up here, pure hypothetical syllogism, to get there. So now I have if C then D. Why would that be useful for me? Well, I can prove not D, or not D is already given as one of the premises here. And if not D, then not C is going to follow. That's just rule modus tollens. So that's going to be line 3 and line 7. And the rule is going to be modus tollens. And then we know how we can use this not C to get not C or P. That's just going to be the rule of addition. So not C or P from line 8 using addition. So if in the process of solving this, you happen to see that you had the possibility to use the pure hypothetical syllogism, you could use that to do your modus tollens, to get your not C, and then use addition. And maybe you started one and you got all the way to line 10 or 11. Again, it doesn't matter how long it takes, as long as you get to the conclusion. You can try to reverse engineer, you can just try to hard break it by doing as many things as you can see that will permit you to do it. And either one of those strategies or something in between, eventually you're going to get to, if you're at least like thinking about where you're headed and paying attention to what you're able to derive, you're going to see strategies eventually for getting to the conclusion that you want. All right. I know I took some time to work on these. Hopefully you worked on them with me as we were going along. I'd really recommend that if you just watch these videos, you at least now go back. If you have that review sheet, actually I'll pull it in here for you. So maybe now a good thing to do would just be to go back to these 4 practice exercises and see if you've learned enough to be able to solve these on your own. These are the 4 that we worked on. It's from the in-class exercises. And now see if, with your experience, you can solve them on your own. You can go back and check to see if you got the right answers. I'll just flash them for you here in case you don't have your actual sheet. So here's the set of solutions. Or you can work through and just start trying to solve, and then if you hit a break, you can hit play and just start running the video again, and that's a good way to work through it. But make sure you didn't just watch this, but you also did the work of trying to solve them, because it's that work which is going to mean that when you actually do it for real on the test, your mind is used to solving these, not just seeing someone else solve it. All right. Good luck.